नेक्स्ट स्टूडेंट जो नंबर 4 क्वेश्चन टा कही तार सॉल्यूशन आम करिया। टू चार्जेस 16 microcoulomb and 9 microcoulomb are 16 microcoulomb and minus 9 microcoulomb are separated by distance 0.08 meter. Let a point A, this is the point B. Now calculate the point where the intensity is 0. Let a point P is the point of observation which is x distance from minus 9 microcoulomb and the total distance from 16 microcoulomb is 0.08 plus x. First, electric field at the point P due to charge minus 9 microcoulomb. Its direction is towards the negative charge, means E1. E1 is equal to E1 becomes beta Q. Q is here 9 into 10 to the power minus 6 by R square, means x square along the direction of PB. Similarly, another, the electric field due to charge minus 6 microcoulomb at the point P. The electric field is here E2. Then E2 is equal to beta 16 into 10 to the power minus 6 0.08 plus x the square along the direction of FP produced. Again, the angle between the two vectors is 180 degree. So therefore the net resultant becomes E is equal to E1 minus E2. According to their question, that is equal to 0. Net intensity equal to 0. So E1 is equal to E2. E1 becomes equal to E2. E1 we have the value 9 into 10 to the power minus 6 by x square equal to beta into 16 into 10 to the power minus 6 by 0.08 plus x square. Beta cancel. Now here we can write 3 by x equal to 4 by 0.08 plus x. Cross multiplied with each other. 4x equal to 0.42 plus 3x, that is x equal to 0.24 meter. This is the point where the intensity is 0. The point 0.24 meter from charge minus 9 microcoulomb. हमें माइनस 9 माइक्रोकोलम रो एतिक डिस्टेंस भितर नेट इंटेंसिटी 0 पाई जाय। Another, a pendulum of mass a pendulum of mass 23.56 into 10 to the power minus 6 kg, then carrying a charge that is of 4 into 10 to the power minus 8 coulomb each at rest in a horizontal uniform electric field. of 1 into 10 to the power 4 volt per meter. Find the tension. Find the tension in the thread of the pendulum and the angle it makes with the vertical. A pendulum of mass 23.56 into 10 to the power minus 6 kg carrying a charge of 4 into 10 to the power minus 8 coulomb is at rest in a horizontal uniform electric field. Is at rest means it is in equilibrium of electric field strength, that is 4 into 1 into 10 to the power 4 volt per meter. Find the tension means force of the thread of the pendulum and angle it makes with vertical. Pendulum, you know, pendulum means simple pendulum, you know, a metallic bob suspended by a rigid support by means of an inextensible, inelastic and weightless string. So now I may consider kariya gote pendulum. This is the rigid support. A pendulum means a metallic bob of mass is given 23.56 into 10 to the power. Mass is given 23.56 into 10 to the power minus 6 kg. Carrying a charge, and a pendulum means metallic bob contain a charge 4 into 10 to the power minus 8 coulomb is at rest in an electric field. को हमें इलेक्ट्रिक फील्ड रखता है 1 into 10 to the power 4 volt per meter. Find the tension of a string means यार हमें टेंशन केते बाहर करिया. We take another position making an angle with inertia. So we can calculate the tension. The bob has weight. The weight's direction is vertically downward. Now, the tension of a string, tension of a string T, vertically upward. It has, this is the angle theta, means this is the angle theta. It has two components. One is the T cos theta and this is T sin theta. When it placed in the electric field, so an electrostatic force is there. आमे जतला ताको इलेक्ट्रिक फील्ड रखिचो तार गोटे इलेक्ट्रोस्टैटिक फोर्स मध्य आमे पाइजो. The metallic bob is at rest at the position. Now the position is here O, A and this is B at the point B. Means it is in equilibrium. The net force is equal to 0. The net force means the weight of a body vertically downward, tension of a string vertically upward and electrostatic force. So we can write the tension can be resolved into two components, T cos theta and T sin theta. T cos theta is equal to weight mg and T sin theta is equal to electrostatic force. That is electrostatic force. We have the electric field equal to F by Q. F means QE, that is equal to QE. Now the tension is equal to, if we get the angle, then tension to be obtained dividing the two factors T sin theta by T cos theta is equal to QE by mg. T cancel, then tan theta is equal to tan theta is equal to QE by mg. We have the all value. आमे समस्तंकर value जानी. Charge is given, electric field strength is given, mass is also given, and G is the 9.8 meter per second square. So substituting all the value, we have the value of tan theta. So theta value आमे table रो बाहर कर परिया. If theta is known, आमे जदि एठो theta रा value जानी गलु, this factor रो जदि आमे theta रा value जानी गलु, आमे tension बाहर कर परिया, because T sin theta equal to QE. Here T equal to QE. QE by sin theta. Q is given, E is given, theta here can be calculated, then tension to be obtained. I am tension the value bahar kari pariya. So these are the some numericals of the electrostatic, means electric field. Next, electric lines of force. Electric lines of force. What is electric lines of force? Electric lines of force is defined as the path, may curve or straight, along which the unit positive charge or to move when free to do so in an electric field. The unit positive charge टा freely electric field रे move कले जो imaginary path हमें पाएगा, सी path को electric lines of force बोले कहते. That is electric lines of force. Electric lines of force is defined as the path straight or curve along which unit positive charge is or to move when free to do so in an electric field. That is the electric lines of force, or it is also known as the flux lines. This is the imaginary line. देखो हमें imaginary line बोले नहीं था. Electric lines of force is a path, may curve or straight. Electric lines of force also defined as the tangent drawn at any point on the curved line given by the direction of electric field intensity at that point. For the different charges, we have the different lines of force. For point charge, if we take the point charge, means isolated charge, the electric lines of force is a straight line. जदि point charge हेइथिबो electric lines of force गुड़ा तो straight line हबो. जदि हमें नबा देखो negative charge, electric lines of force isolated negative charge, electric lines of force is also straight line. That is positive charge, isolated positive charge, and this is the negative charge. If we take the pair of charge, then the electric lines of force is a curved line. हमें यदि ताको pair of charge नबा, that is positive charge, here negative charge. The electric lines of force is a curve. Electric lines of force is a path. It is always starts from positive charge and towards the negative. that is the pair of dissimilar charges. This is the representation of electric lines of force, pair of dissimilar charges or opposite charges. If the two charges are similar of nature, that means the electric lines of force, they should be repel with each other because two charges are similar of nature. This is the electric lines of force for similar charges. Now, some properties of electric lines of force. Some properties of electric lines of force. किछि properties आमे देखिवा electric lines of force. First, electric lines of force are always start from positive towards negative. Electric lines of force are always away from positive charge, away from positive towards negative. Second, electric lines of force are never intersect with each other. Electric lines of force टा केबे परस्पर क्रॉस करंती नहीं. Electric lines of force are never meet with each other. Electric lines of force are never cross with each other or never intersect with each other. Then third, tangent drawn at any point on the curved line given by the direction of electric field intensity at that point. If we tangent draw on the curved line given by the electric intensity at that point, why the two lines of force are never intersect with each other? If the two lines of force are cross at a common point, two tangent are drawn, it given by the two direction, it is not possible because it is a one field. Therefore, the two lines of force are never intersect with each other. Then fourth properties, the lines of force per unit area is proportional to strength of electric field. The lines of force per unit area is proportional to strength of electric field. Strength of electric field. If the lines of force are more per unit area, then the strength of electric field also more. If the lines of force per unit area is less, then electric lines of force, electric field strength also less. So then fourth, the lines of force are contract longitudinally in case of two dissimilar charges. Lines of force are contract longitudinally means lengthwise. Longitudinally means lengthwise. Then fourth, lines of force exert lateral pressure in case of two similar charges. If the two charges are similar of nature, then the lines of force exert lateral pressure. Fifth, then sixth, the lines of force are never passes through the conductor. The lines of force are never passes through the conductor because due to absence of electric field. Then 7, the lines of force meet normally in case of spherical conductor. If we take the spherical conductor, then lines of force are always outward direction. That means lines of force are meet normally in case of spherical conductor. Then 4 pi lines of force carries each unit positive charge. 4 pi lines of force carries each unit positive charge. These are the some properties of electric lines of force. If we take the diagrammatic representation of electric field in terms of lines of force, diagrammatic representation of electric field. There are two types of field. One is the uniform field and other is the non-uniform field. Uniform field means the strength of electric field are equal. So it can be represented by uniform field. Jodi ame lines of force guda ko parallel naba. If the lines of force are parallel with each other, that indicates the uniform field. Now, if the lines of force are parallel with each other, perpendicular to the plane inward direction, outward direction, this is represented by point. If the lines of force are parallel, means uniform field perpendicular to the plane inward direction, that indicates the cross line. This is the representation also uniform electric field perpendicular to the plane outward direction, and this is the uniform field perpendicular to the plane inward direction. If the number of lines of force are more, that indicates the strong field. If the lines of force, the number of lines of force are less, that indicates the weak field. Non-uniform field. What is non-uniform field? The strength of field are not equal at all points. That is, if the lines of force are apart, that is a non-uniform field. If the lines of force, that is a non-uniform field. The strength of a field हमें आइदर कन्वर्जेंट भी देखि परिया, डाइवर्जेंट भी देखि परिया. That is also non-uniform field. These are the diagrammatic representation of electric field. Now, electric dipole. What is electric dipole? Dipole means it consists of two equal and opposite charges separated very close to each other. That is called electric dipole. Dipole means it consists of two equal and opposite charges separated very close to each other. That is called electric dipole. Two charges Q and Q, that is one is plus Q and other is the minus Q, separated by distance A, that is the electric dipole. O is the center of dipole. A dipole has two lines. One is the axial line of electric dipole, or that is also called as the end-on position. And other is the equatorial line, or that is called broadside on position. End on position, then broadside on position. Axial line and other is the equatorial line. What is the axial line of electric dipole? A line joining between two equal and opposite charges passing through the center of dipole is called the axial line. A line joining between two equal and opposite charges passing through the center of dipole is called the axial line. Then equatorial line. What is equatorial line? a line passing through the center of dipole and perpendicular to the axial line, that is called equatorial line. A line passing through the center of dipole and perpendicular to the axial line, that is called equatorial line. Now next, dipole moment. What is dipole moment? Dipole moment of an electric dipole is defined as the product of either charge and distance of separation between them. It is represented by P. P is a vector quantity. आमे dipole moment कहले कौन बुझो ना, dipole moment means it is the product of either charge and distance of separation between them. It is a vector. Dipole moment is a vector, means it has direction. Its direction is always opposite to that of electric dipole. Dipole means its direction is away from positive charge towards negative charge. माने आमे पॉजिटिव रु नेगेटिव बोली जानितलु, बट आमे जेता डाइपोल मूवमेंट देखिबा यार डायरेक्शन हला नेगेटिव चार्ज टुवर्ड्स पॉजिटिव. Unit in SI system, P equal to A into Q. A is here meter, charge is here coulomb, that is coulomb into meter. The unit is coulomb into meter. And the dimension of dipole moment. A is the distance, means length. Charge is the fundamental quantity, that is AT or ATL. This is the dimension of dipole moment. So what is ideal electric dipole? What is ideal electric dipole? A dipole, the magnitude of charge tends to infinite and distance of separation them is 0. That is called ideal electric dipole. Next हमें पढ़िबा इलेक्ट्रिक फील्ड ड्यू टू इलेक्ट्रिक डाइपोल. हमें इलेक्ट्रिक फील्ड बाहर करिके आसछो का पाई ना, इलेक्ट्रिक फील्ड ड्यू टू पॉइंट चार्ज पाई बाहर करिके आसलो. इलेक्ट्रिक फील्ड पॉइंट चार्ज यूनिफॉर्मली डिस्ट्रीब्यूटेड सर्कुलर रिंग पाई बाहर करिके आसलो. तो नाउ इलेक्ट्रिक फील्ड मीन्स इलेक्ट्रिक फील्ड इंटेंसिटी बाहर करिवो कहा पाई ना, ड्यू टू इलेक्ट्रिक डाइपोल. Dipole has two lines, one is the axial line and other is the equatorial line. अर्थात हम axial line रे भी इलेक्ट्रिक फील्ड स्ट्रेंथ केते बाहर कर परिउ एंड इक्वेटोरियल लाइन रे मध्य बाहर कर परिउ. तो नेक्स्ट क्लास रे हमें पढ़िया इलेक्ट्रिक फील्ड ड्यू टू इलेक्ट्रिक डाइपोल. हमें इलेक्ट्रिक फील्ड बाहर करिया इलेक्ट्रिक डाइपोल. तार आम फास्ट केस 1 टा देखि परिया, पॉइंट इज सिचुएटेड ऑन एक्सियल लाइन ऑफ इलेक्ट्रिक डाइपोल और दैट इज द एंड ऑन पोजीशन. आम फास्ट बाहर करी तार एंड ऑन पोजीशन रो इलेक्ट्रिक फील्ड स्ट्रेंथ केते, देन पढ़िबा तार इक्वेटोरियल लाइन दैट इज ब्रॉड साइड ऑन पोजीशन रो इक्वेटोरियल तार इलेक्ट्रिक फील्ड स्ट्रेंथ केते बाहर करिया. तो नेक्स्ट हमें पढ़िया. थैंक यू.